Sige.
Today, it's more on siguro review doon sa electrochemistry, and then i-ano natin yung principles. In the next meeting, pupuntahan natin yung tatlong electroanalytical chemistry that we're going to tackle on. So, i-send ko na lang sa inyo yung material because I'm trying to at least select the best material that I want you to have. Teka, ano natin. Share ko lang sa inyo. So, dito tayo sa field ng tinatawag na electroanalytical method or electroanalytical chemistry. So if we're going to look at this, it encompasses a group of quantitative analytical methods that are based upon electrical properties, okay, of a solution of the analyte when it is made part of the electrochemical cell. So kailangan dito yung tinatawag nating electrochemical cell. So everything that is being done there has a setup, okay, similar to electrochemical cell. Noon malaki siya, ngayon pwede siyang parang strip lang. Okay? So if we're going to look at these electroanalytical methods, marami siyang advantages over, we could say, the other analytical methods that we have discussed. I listed some here, although marami pa bukod dyan. So we could say specific siya for a particular oxidation state of an element. So ang principles kasi ng electrochemistry is, we know, based on your general chemistry, yung tinatawag nating redox, the reduction oxidation reaction, the electron transfer. So hindi lang siya specific, it can also be selective for a particular redox state of a species. So let's say meron kang copper na gagawin mong copper plus, or which can further oxidize to copper 2 plus. Okay? Tapos ito yung maganda, it's relatively inexpensive. Okay? Usually yung cost nito, I was able to buy a portable one around this year, no, I think 2 years ago, okay, with the project that I have in the Philippines, just around 9K, okay, 9K to 25K. So this is the portable one. This is the benchtop that I have in the lab, okay. So this is already, we could say, comparable doon sa performance nung tinatawag nating mga 50K to 100K na instrument, let's say sa spectroscopy, or like a spectrophotometer. Okay, and the good thing about it provides information about activities. So we will have some sort of a review of this rather than concentration. Okay, and what makes this I think more popular is it's very rapid. Okay, I don't know if I mentioned in this class or in 230 that electroanalytical chemistry has the so-called billion-dollar industry. Okay? Kung diabetic ka, meron kang ginagamit na sugar meter. So that is an example of a product of electroanalytical chemistry. So halos lahat ng tao, I mean, most of the people around the world are diabetic, including myself. So I always have this sugar meter with me. And if you're going to look at this, all you need to do is get a drop of your blood sample and then put it there. You can read already the sugar level that you have. Okay? So, pwede rin natin sabihin na it's in situ. Okay? And it can give you a lot of info doon sa oxidation state, sa stoichiometry, okay, sa rates, sa charge transfer, tsaka sa equilibrium constant. So there's a lot of things that you can do in electrochemistry. In fact, this is one of the big 3 in analytical chemistry. Okay? Yung other big three ay yung tinatawag na chromatography at electrochemistry. Although nagiging part na rin ito, yung big four ngayon yung mass spec. Okay? Because if you're going to look at the field of electrochemistry, so tinitingnan niya usually dito yung analyte in terms of their potential, current in an electrochemical cell containing the analyte. So the three main categories na itatackle natin but not today ay yung tinatawag na potentiometry, the difference in electrode potential measured. Classic example nito ay yung tinatawag nating pH meter. If you were able to measure pH using the pH meter, that is a product of potentiometry. Tapos meron tayong coulometry. So this is based on yung tinatawag na nating unit na coulomb. Coulomb is what? Unit siya ng ano? Anong quantity? Anyone? If potentiometry we could say is the potential, this one has something to do with a unit of charge. Okay? Now, coulometry is not, we could say, as popular as potentiometry. In fact, in other electroanalytical chemistry lecture, they just focus on potentiometry and yung tinatawag na voltometry. So in the voltometry, what it do, it measure the cell current while changing the potential. Okay? Now, yung tinatawag nating sugar meter, it's a product of amperometry. Okay? Na derivative siya ng voltometry. Okay? So as I've told you, or if you watch the other notes or lecture that I posted that I delivered for Chem 230 class, electroanalytical technique is really, we could say, a big field. Okay? So it can be an interfacial method or a bulk method. Now, if it's a bulk method, all you need to do is conductometry. So you just look at the conductivity. So you can do a conductometric titration or a conductometry. Okay? But the one that we usually look is it's either you have a static method or a dynamic method. So yung tinatawag na interface. And naka-highlight dito ano yung talagang i-concentrate natin. Okay, so in a static method, we can have potentiometry or potentiometric titration. Okay, now doon naman sa dynamic method. So when you say static method, the current is equals to 0. Now in the dynamic methods, the current can be more than 0. It's always what we call more than 0, and it depends if you want to use a constant current or one wherein the potential is the one that is being controlled. So if you're going to use a dynamic method whose current is constant, so you can either use electrogravimetry or coulometric titration. Okay, but if you're going to what we call use a controlled potential, you can either end up with amperometric titration or voltometry. So nilagay ko ng spade yung itatackle natin dito sa chapter na to. Okay? So you can also have a constant electrode potential coulometry or electrogravimetry. And just to show you, to give you an idea, what are these, what we call three methods before we go back to that most likely next meeting. Okay? So meron tayong tinatawag nitong potentiometry. So it measures the potential of electrochemical cells without drawing substantial current. Okay, so possibly measures the potential of a solution between two electrodes, affecting the solution very little in the process. So the potential is then related to the concentration of one or more analytes. So ang specific ano dito yung pH measurement, yung ion selective electrode, so yung tinatawag na ISC, at pwede ka rin magagawa ng potentiometric titration. I'm not sure if you use an acid-base titration na instead na yung indicator lang ang ginagamit, meron kayong pH meter. And then, i-add nyo yung base. So, ganyan yung parang results ninyo. So, that's a potentiometric titration. Okay? Now, on coulometry, on the other hand, it measures the electricity required to drive an electrolytic redox reaction to complete. Okay? So, usually, it involves titration, ay yung tinatawag nating chloridometers. So, this is adding chloride to silver. Okay? Because when you add silver ion to chloride, an argyrometric titration, usually you will have precipitate. Okay, so the last one, where I got able to do some research when I was still part of IC, I think 18 years ago. Okay, yung tinatawag nating voltometry. So here, it measures the current as a function of applied potential under conditions that keep a working electrode polarized. Okay? So example dito yung tinatawag nating cyclic voltometry and other biosensors. So if you have watched already the 230 lecture that I have posted in Facebook group, you will see some example there, okay, of the voltometric analysis that I have done. But before we go on this, we will tackle that next week. So let's review this, what we call the redox reaction. So when we're talking about redox reaction, usually meron tayong tinatawag na electron transfer. And I don't know how you learn it, but do you still know what this means? Tinuro ba sa inyo to sa Gen Chem? Class? Dun sa anim na nandito. Do you know what Leora and Jeroa means? So it's still applicable here. So siguro pang ano na lang to review, just to see if you still understand what you have. So when you say Leora, di ba, lost electron, oxidation, and then reducing agent. And then Jeroa is gain electron, reducing reduction, and then oxidizing agent. So let's try to do some, let's say, balancing redox reaction. So both gawin natin acidic and then basic solution. So this is just some sort of a review, because when you're talking about electrochem, it's really about redox. Sabi nga nila, there are two types of electrochem. Either you have a spontaneous reaction that produces electricity or energy, or you use electricity or energy to make a non-spontaneous reaction go to what we call reaction. Okay, so you use the energy or you produce the energy. So if we're going to look at this, I don't know how you do it, but we can have this half reaction method. So we can put the Fe2 plus with the Fe3 plus. So ano ito, na-oxidize or na-reduce? Ano nangyari when Fe2 plus is converted to Fe3 plus? Just a review. So baka nakalimutan nyo na or iba yung natutunan nyo. Maybe, okay, the way we're going to learn here will give you another perspective. So this is the one that is oxidized. And usually what we do is we balance all elements first. Okay? And in this case, balance na siya. Ang hindi lang balance sa kanya ay ano? Yung charge. We have a +2 here and +3 here. So we could put an electron on this one so that the charge is balanced. Now on the second half reaction here, since this is oxidation, so masasabi natin ito yung reduction half reaction. So the rule that we have here, if there is an oxygen, ano yung gagamitin natin pang balance sa oxygen? If you still remember. Okay, so you have 2 chromium here, 1 chromium here, so dadagdagan natin yan. And then you have 7 oxygen here. So when we have oxygen, ano yung pang-balance natin? If you still recall, we're going to add water. And when we introduce their water, okay, nag-i-introduce din tayo ng hydrogen. And to balance that additional hydrogen, we also add an H plus, right? So, review lang to, but I hope if you have not able to pick it up well during your Gen Chem or 32, okay? So hopefully may matutunan pa rin kayo. So if you're going to look at here, so we look at the chart since all the elements are balanced. So makikita natin dito, there's a plus 6 on this side and this is what? Plus 14 minus negative 2. So you have plus 12, right? So to balance it, magdadagdag ka ng what we call 6 electron because there's a plus 6 there. So you have these two already. Iko-combine natin and then we have this. So if you know this one, then good. If not, then hopefully you can learn something. So all we need to do now is make sure they have the same number of electrons because ang main definition ng redox reaction is a transfer of electrons. So the electron that was lost should be equal to the electron that was gained. So in this case, kailangan i-multiply mo to ng 6. And then you cancel them out and then bring down everything. Most of the stuff that we're going to have today is just a review doon sa electrochemistry nyo. So ito yung tinatawag natin ngayon, acidic solution. So you double check Fe, Fe6, and then chromium, chromium 2, 7 oxygen, 7 here, and then 14, 14. And then in terms of charge, so this is 6 times 2, that's plus 12, minus 2, and then plus 14. So if you're going to add everything here, so this is equals to what? 14 plus 12, that's 26, minus, that's plus 24. And here you have 6 times 3, that's plus 18, plus 6. So you also have plus 24. And then from here, you can make it also in basic solution. Do you still recall what to do? Ito lang yung balancing natin. After this, we're going to go to Electrochem, the Galvanic and the Electrolytic cell. Okay? So after we move here from acidic to basic solution, so what we do is we're just going to add OH minus, right? Para doon sa tinatawag nating basic condition. Okay, so we add OH minus to both sides of the equation for every hydronium ion. So you have here an H plus, so you add 14 OH minus, so plus 14 OH minus. So ano nangyari dito? Magkakaroon ka ng 14 H2O. Since you have 14 here, you have 7 here, so maka-cancel out to. So you will have here 7 H2O. And then you just bring down everything. (14OH minus). Oh, wala na yung 14OH minus. It's 7H2O. And then on the other side, you have 6Fe3 plus 2Cr3 plus, and then there's where you have your 14OH minus. And then you look at the number of elements on both sides, 6Fe, 6Fe, 2 chromium, 2 chromium. Oxygen is 7 here, plus 7 here, so that's 14, which is also 14 here. And then hydrogen is 14, and then hydrogen 7 times 2 is 14. And then you have here a plus 12, a -2 that makes it a +10. And this is an 18 plus 6 minus 14. So that makes it +10. So balanced na siya. Okay? So this is what we call just a review. And the succeeding, we could say, slides that we have here are just, we could say, review of what you have learned so far doon sa electrochem. Okay? So are you still familiar with the electrochemical cell setup? Tandaan niyo pa kung ano meron siya. Okay? So what do we usually have in an electrochemical setup? Anong tawag natin dito? So we need 2 electrodes, right? And then each electrode is dipped in, anong tawag natin sa solution na yan?
Ionic.
Is it ionic? Or yung tinatawag nating electrolyte solution. Okay? And then we need this wire, yung external connection between the electrodes. So usually we use some sort of a wire. And then we also have an internal connection. Okay? At ano yung tawag natin dun sa internal connection na meron tayo? Yung tinatawag na salt bridge. Okay? So, what happened here? What's the function of the salt bridge? Or maybe kapag inano natin, okay? So usually, yung flow ng electrons, right? If you're going to look at this, it's coming from this side, going to this side. So we could say, ano yung nangyayari dito? Anong reaction itong side na to? When zinc is converted to zinc 2+. So yan yung anode. And usually what happened in the anode? Anong redox? If you still remember. Okay? So that's where oxidation happened. So these are the basic thing na pwedeng lumabas sa board exam ninyo. Okay? And then you have here reduction. So if you're going to look at here, okay, oxidation is where you lose your electron. Reduction is where you gain electron. Now what happened to the charge? Ano nangyayari sa charge dito? Since it gains the electron, it becomes what? Di ba negative charge? And this one, since you lose electron, you have what? A positive charge. But what prevents that from happening? Bakit hindi nag-accumulate ng negative charge dito sa cathode at hindi nagkakaroon ng positive charge dito sa anode? It has something to do with the salt bridge. Okay? So yung salt bridge, yun yung parang nagme-maintain yung electron neutrality. So what happened? The cation in the salt bridge, for instance, the K+ here, it will go here. And the Cl- will go here. So tandaan nyo pa yan? So is this new to you? And if you're going to look at the net reaction here, paano natin isusulat yan? So we just add what's happening here. So if we're going to look at this, so zinc. So I know you could say, oh, ginatuhan na natin yan, but this is the basis of what we're going to tackle. And then you have your copper 2+ plus 2 electrons, and then you have here copper. And then, so the net reaction that we have is zinc plus copper 2+ producing zinc 2+ plus copper. Now, if you're going to allow the reaction to happen, ano yung ma-observe nyo? So usually, yung copper sulfate, ano yung itsura niya? What is copper 2+? Usually, what color is it?
Blue po.
Blue. So what do you think happened if you allow the reaction to proceed? So from time, ano mangyayari doon sa zinc metal? Kung inallow mo lang siya mag-proceed, let's say you leave it for a day or for a week. So if that happens, you will see that after some time, your zinc metal is gone. Wala na siya, magpa-transform na siya sa zinc 2+. Tapos yung blue color solution mo ng copper magiging lighter, and you will see that there's a shiny brown color doon sa surface ng copper electrode. That's what happened. Okay? So if you're going to look at this one, usually meron kang makikitang potential dito. Okay? So if you're going to look at the potential of the overall cell, it's just a measure of the tendency of this reaction to proceed to equilibrium. And usually at equilibrium, parang ano lang to, Chem lang to. What is the cell potential at equilibrium? Anyone? Usually at equilibrium, yung cell potential natin 0. Okay? So anong ibig sabihin ngayon itong cell potential na to? Okay? So if you have a larger cell potential, the further the reaction is from the equilibrium, and the greater the driving force that exists. So usually ang mangyari dito, magpro-proceed lang yung reaction, magpro-proceed to until ma-reach na niya yung equilibrium. Okay? So isipin nyo na lang yung potential kapag parang ganito. So between the two, if this is the potential, so which one has the higher potential? A or B? So between the two, alin yung magpe-favor? The one with the higher potential will be favor. Okay? So ganun yung nangyayari dyan sa setup na yan. And then we go to the specific what we call electrochemical cell. So meron tayong tinatawag na galvanic cell or voltage cell or Daniel cell. Okay? So usually if we're going to look at this type of cell, ano masasabi natin sa galvanic cell? Ano yung cell potential niya? Usually it is what? Ano yung sign niya? This is a positive sign. Okay? And usually if you're going to look at the delta H of that, that's an exothermic reaction. And if it's an exothermic reaction, ano ibig sabihin nun? May pro-produce siya ng energy. Okay? So we could say a galvanic cell would also have what? A spontaneous reaction. So in terms of delta G, ano yung sign ng delta G? Review lang to.
Negative po.
Okay? So a spontaneous reaction will give you a negative sign. And in terms of K, ano yung masasabi nyo sa value ng K? Okay? It's always more than 1. So I'm not sure if you're still familiar yung tinatawag nating mga formula na gaya nito. Okay? So this is how you relate the delta G with the cell potential. So a positive cell potential means a negative cell potential. A negative cell potential means a K that is more than 1. Or a positive cell potential means a K that is more than 1. So yan yung galvanic cell. Okay, so that's the one that has a spontaneous reaction to produce energy. Now the other one, okay, you need an external battery. And the external battery should have a higher power than the cell potential. So in an electrolytic cell, you use energy. Okay? So that means the reaction will not happen on its own. the reaction will not occur naturally. It requires some sort of an external stimulus, like an energy, for the reaction to occur. So that means yung delta E mo ay negative. Okay, yung cell. Tapos yung delta G mo ay positive. At yung K mo ay ano?
Less than.
It's less than 1. And if you're going to look at the delta H, usually this is endothermic or positive because you need energy. Okay? Now, you also have to know that there is some so-called chemically reversible cell. So, anong ibig sabihin nitong chemically reversible cell? So, this is a type of cell in which reversing the reaction or reversing the direction of the current simply reverses the chemical reaction. Okay? So, meron tayong tinatawag na chemically reversible cell, a cell in which reversing the direction of the current simply reverses the chemical reaction. Now here, both electrolytic or galvanic cell, okay, if you're going to look at here, yung direction ng electron niya, it's always what? From A to C, from anode to cathode. So ibig sabihin, whether you have electrolytic cell, okay, or galvanic cell, oxidation always happens in the anode and reduction always happens in the cathode. Okay? Kasi yan yung next na ano natin eh, yung tinatawag nating electrode. So meron tayo yung cathode. So usually, that's where reduction takes place. Okay? So if this is where reduction takes place, so that means yung electron mo ay nasa reactant side. Because reduction means gain of electron. Now, on the other hand, if you have the anode, that's where oxidation takes place. In this case, we could say that that's when electrons, what we call, you lose your electrons. Okay? So, whether you have a cathode or what we call an anode, okay, what happened here is the electrons that you have in the anode, it can be supplied by current via electrode. Okay, so the species that you have here, products and reactants, can both be in solution. Okay, or we could say solids or coated on electrodes. So pwede siyang nasa solution, solid, or yung tinatawag nating coated. Kasi yung natutunan natin sa Gen Chem, you have a metal electrode and an electrolyte. Okay, unless meron kang platinum, okay, which is an inert electrode para doon sa non-solid na tinatawag nating element. Okay, now for the anode, usually the electron is taken up by electrode into the circuit or electrical circuit. Okay, now one thing that we have not learned, and maybe this is the first time that you are introduced to this concept, ay yung tinatawag nating liquid junction. Okay, so liquid junctions, these are the interface between two solutions with different components or concentration. Okay, so here makikita natin yung junction natin dito ay yung between yung tinatawag nating electrolyte at saka yung salt bridge. Kasi iba yung component dito eh. So you have here a copper sulfate And then you have here a KCl. So most likely yung K plus ang mag-i-interact doon sa copper 2 plus mo at sa sulfate ion. And on this junction here, okay, ang mag-i-interact doon ay yung zinc 2 plus at yung sulfate with tinatawag nating potassium ion. Okay? Now, the electrochemical cell that we know usually separate yung solution natin. Okay? But you can have a galvanic cell without the so-called liquid junction. So kung yung setup natin ay parehong ganito, usually may presence ng liquid junction. But you can have a cell wherein there is no liquid junction, like the one that we have here. Okay, so this is a galvanic cell without a liquid junction. Kasi pareho lang yung composition niya eh. Okay, so ang mangyayari dito, you have two species that have high potential for the reaction, but the reaction we could say is what? Slow. Okay, you have to mix the two species directly into a common solution. And usually this type of galvanic cell without cell junction, this is not common, but it's still possible. Okay, so yung pagkakaiba lang dito, meron kang coated na ano dito, silver. Okay, so wala itong tinatawag nating cell junction. Now another thing that you need to know, which I hope you learned from your Gen Chem, I think Gen Chem 2, right? If I'm not mistaken, ay yung tinatawag nating cell notation or representation of the cells. So for instance, if you have this cell, how are you going to write the cell notation for this? Tatandaan nyo pa yung A, B, C. I don't know if that's how you were taught in writing the cell notation, because that's how I teach my students here. So here, this is what? Your anode. This is your cathode. And your B is your salt bridge. So meron ka dito, ipa-follow mo lang yung species na nandoon and you put a bar to represent difference in phase. So you can put it like this one, and then ilalagay mo yung tinatawag nating activity of zinc 2 plus. So let's say nakalagay dito 0.01. Okay, and then you have two liquid junction. Okay, two bar line there, and then you put the copper sulfate, and then you put there the activity copper 2 plus, kung ano man yung nakalagay doon, 0.01, and then copper. You still remember that? Maybe in your Gen Chem level, ganito lang yun ginawa natin, right? And then you put there 0.01, tapos it's not copper, but it's a cup. Medyo na ano kasi itong pad ko eh. Molar pa nga ginagamit natin doon, and then copper 2 plus 0.01 molar. And then, but at this level, since we don't use concentration, we use what we call a PBT. So this is how you write yung tinatawag nating cell notation. Okay? And you also learn about this concept ng tinatawag nating electrode potential. Okay? And if I'm not mistaken, this is really not a standard electrode, but the so-called reduction potential. So the way that you do it for convenience, you represent the overall reaction in cell as 2 half reaction, one happening at the anode, which is the oxidation, and one happening at the cathode, which is the reduction. And then each half reaction has certain potential associated with it. By convention, we write both half reaction as reduction. So for instance, yung sa cathode, write natin na ganito. Yung sa anode, i-write natin na ganito. But we put there a negative sign to denote that is what we call the one that is undergoing oxidation. And if we want to get the potential of the cell, we define it as this. Okay. Now, how did they end up getting the electrode potential? Ano yung history niyan? Okay. Because we all know we cannot directly measure the potential. So that's the main problem. You cannot measure potential of just one electrode. What they do is they compare it with another electrode. Okay. So the way that they do it, they determine the potential of all half reaction versus a common reference electrode. And that reference electrode is your SHE. And if we're going to look at this SHE, that's the standard hydrogen electrode. Since wala siyang, hindi siya pwedeng maging solid, you use a platinum electrode. And the condition would be 1 atmosphere and an activity, okay, of 1 if you're going to look at the standard hydrogen electrode. At ito yung reaction niya. You have a stream of hydrogen that keeps the surface of the electrode saturated with hydrogen gas. And if you're going to look at this, it's the potential that is affected by the pH or the H+. And it is used as an early pH indicator. And it is dependent on the pressure of the hydrogen. So ito yung parang typical na SHE na ginagawa nila. And what they do, you're going to match your SHE with any other electrode. Okay? O yung tinatawag natin electrode of different metal in its respective electrolyte. So by convention, they assign the value of the standard hydrogen electrode as 0. Why do you think they assign it as 0? Anyone? Why do you think they assign the potential or the reduction potential for the standard hydrogen electrode as 0? Anyone? Naalala niyo ba ano yung reason doon? Okay. Because if you're going to look at the reaction that is happening, so this is what you have, right? So if the reaction is reversed, like this one, your reduction potential there is still equals to 0. Okay. So by definition, okay, you can get here in this what we call the potentials of other electrons that are compared to the standard hydrogen electrode in question as cathode, and the standard hydrogen electrode as anode. So in that case, kung ano yung potential ng cathode mo, yun yung makikita mong reading. Kasi yung standard hydrogen electrode mo serve as an anode. So anything, okay, that we could say has a higher reduction potential than the SHE will serve as a cathode, and the SHE serve as an anode. And anything that has a lower reduction potential than the SHE, the SHE will serve as a cathode, and the other one will serve as an anode. Okay, so ang nangyari dito, the one that you learned before, everything is equals to what? a concentration that is equals to 1 molar. But at this level, you have to take into consideration that the measured cell potential when all species in solution or gas should have an activity that is equals to 1. I'm not sure if you know the concept of activity. Were you able to take this in 32? Class? I'm not familiar with 32 because it's been a long time. Okay? But usually activity is proportional to what? The molar concentration. Yung definition ng activity, okay? Sa PChem. Sa bagay, meron tayong D by Haeckel later dito eh. So, the activity is just equals to the activity coefficient of the solute X times the molar concentration of solute. Okay? So at this level, a higher level ng chem, instead of using concentration, we focus more on the activity. Okay? So ang ano nga dito, kapag yung cell potential mo is positive, it indicates that this reaction takes place. Okay? So it is favored and spontaneous. So that means the Mn2 plus is readily reduced by hydrogen. And Mn plus is a better electron acceptor or oxidizing agent, because that's the one that undergo reductions. That if the electrode potential is negative, it indicates that the reaction is not favored or is spontaneous, and it requires energy to proceed. And the metal is readily oxidized by H+. So mas mataas yung reduction potential ng hydrogen. Okay? So the metal is a better electron donor or reducing agent. Okay? So doon sa reduction potential na ano natin, as the reduction potential increases, it oxidizes the other reaction. So usually the more positive that you have here, what happens is it undergoes reduction, it is a better oxidizing agent. Now the one that has a more negative cell potential or reduction potential, it easily oxidizes and is a better reducing agent. Okay? Now, Nernst equation. I-review pa lang to lahat na inaano natin to introduce you to that concept. So Nernst equation would look like the effect of concentration doon sa given potential. Okay? So here you could say the values of the cell potential of the electrodes can also be calculated at other concentrations or activity of species. So for a given hot reaction, you have this P of P plus Q of Q plus the number of electrons producing R of R plus S of R. And if you're going to write that, this is how the Nernst equations looks like. Okay, the potential of the electrode equals to the standard cell potential minus RT over NF times Ln of the activity, products of the activity of the products over products of the activity of the reactants. Okay, and at this level, usually you can get the calculation separately in your electrode. So at room temp, yung tinatawag nating RT over NF, you can simplify it as 0.02569 divided by the number of electrons that is involved. You can also use it in terms of log. Okay, 0.0592 over N. Now, if you know the standard cell potential, it allows you to determine the potential of the electrode. Kita nyo, it's a potential of the electrodes here. Okay, to be calculated under non-standard condition. If all activity values is equals to 1, okay, your cell, the potential of your electrode is just equals to your standard cell potential. Because what happened here, you will get what? Log of 1, and log of 1 is just equals to 0. So magiging 0 yung expression na to kapag yung activity mo is equals to 1. Now, once you have the potential of the cathode and the potential of the anode in negative, you can also get the potential of the cell. And here, you may also need to include the junction potential, but we just put some sort of approximation here. So the thing that you need to remember at this level, okay, you do have to do the calculation twice. Once for the anode electrode, once for the cathode electrode. And there's always a common mistake, especially from the Gen Chem level, to simply do the calculation once and report the cell, the potential of the electrode as E cell. So usually, ang alam lang natin from Gen Chem parang ganito. Right? Kung ano man yung number na meron tayo dito. Okay? But the one that we have here is really the electrode. And I think I have one example here. But before we go with that example, this is just a short discussion. Okay? So you didn't take it in analytical, right? Because I teach this in my analytical here. So you learn this from your PChem. Okay? So when you're talking about activity coefficients, okay, it's just the experimental determination of the individual activity coefficients that appear to be impossible. So what you do, you can determine the mean activity coefficient. And the way that you do it is the activity coefficient is just equals to the activity coefficient of A or ion raised to whatever the charge, and then activity coefficients of the other ion raised to the whatever the charge that it has. And to get the log of YA, you usually has the so-called Debye-Hackel equation. Okay? So ito yung ginagamit mo. Although there's already a table that is available telling you the given activity coefficient at a certain ionic strength. So ito yung common. Okay? Now, the Debye-Hackel equation is not applicable if your ionic strength is more than 1. So try natin mag-solve. Siguro yung problem natin na ano parang ganito lang. Okay, so calculate the potential. I think this should be a potential of the electrode for the cell that has this. Okay, platinum with hydrogen 1 atmosphere and HCl at 3.25 times 10 to the negative 3 molar. And then you have a silver chloride that's saturated and silver. And you have here the half reaction. So maybe ang gagawin natin dito, naanuhin natin yung sa cathode, right? And then we get the reduction potential there of silver chloride, okay, minus 0.0592. Ano yung N? Ano yung N natin dito? Since we only have one electron here, so that's 1. So ano yung kailangan natin dito? Yung activity coefficient ng chloride. But we could see here, since this is what? Saturated siya, so we can assign it as what? 1. Right? So we can convert this log activity of chloride is equals to log of chloride times the concentration of chloride. Okay? So saan natin kukunin itong coefficient, yung concentration ng chloride na to? I think we're going to use that. So we're going to replace this with what? 0.222 minus 0.0592, and then what do we get here? Log of the activity coefficient here, yung equivalent niya, I think it says Here, the chloride. Ano ba yung concentration niya? Saturated. So we could say 0.939 times the chloride concentration there is 3.215 times 10 to the negative 3. So ano yung makukuha natin dito? Now you might ask, where did we get the 0.939? We get it from the D by Haeckel equation. Given the mu as equals to 3.215 times 10 to the negative 3. So ano makukuha natin dito? Anyone? Before we go with the anode.
Point 3712.
0.37. Okay. Now, if we go with the anode, so ano yung gagawin natin dito sa anode? So that would be in the H minus 0.0592 divided by 1, right? Hindi siya 2 kasi 1/2 yung nakalagay eh. So we have a 1 electrons here, and this is log activity of the H plus, and we can incorporate also here the pressure. So we have here what? 0 minus 0.0592 and then log of H plus yung ganito times the concentration of HCl, which I think is also given there, times 1 atmosphere. So ito eh, yung 3.215 din. And from D by Haeckel, okay, if we have that number, ang makukuha nating activity coefficient is around 0.945. Okay? And if we have that, 0, 0 minus 0.0592 times log of 0.945 times 3.215 times 10 to the negative 3 times 1 atmosphere. And what do we get?
Point 149.
So that's 0.149. And then to get the cell, all we need to do is what? 0.371 minus 0.149. And you're going to have here equals to what? 0.22, right? Tama ba?
Yes, bro.
Tapos isipin nyo, pinahirapan ko lang kayo kasi pwede namang gamitin ito minus this one, right? You follow on that? But I'm just showing you here, okay, that if you're going to consider that the cell potential here is really the potential of the electrode, you have to do each calculation in terms of the cathode and the anode. And in theory, dapat katulad pa rin siya kung ginawa mo yung cathode minus anode, which is 0.22 minus 0, which is also 0.22. Okay? So, ganyan lang siguro yung calculation natin dito sa part na to. Now, the limitations that we have in this type of calculation, we could say the cell potential is based on activity. not concentration. Okay, so the activity that we have will be equal. Activity is equal to the concentration only in dilute solution. At higher concentration, you need to determine and use the activity using this definition. So for example, if you have Fe3 plus an oxidized with an electron to Fe2 plus, so the cell potential is 0.771 volts. But the electron at 1 molar is 0.732 since the activity is less than 1. Okay, so there's a problem if the activity coefficient is not known from calculations or previous experimental studies. And in addition, you have to look at the side reaction that can affect the what we call potential. So example, the same system that you have here, but if you have different acid, you're going to have different cell potential. If it's in perchloric acid, that's 0.73. If it's at HCl, it's 0.70. If it's in phosphoric acid, it's 0.60. Now, the reason here is because both the Fe2 plus and Fe3 plus, they form different complexes with the Cl minus and the phosphate. And that results to changes in the net activity of the Fe2 plus and Fe3 plus in the solution. So sometimes the way that we learn it in Gen Chem, simplify natin. But if we're going to look at them into details, you will see that there are really some problem. Okay? Yung akala natin, oh, ito na yung activity, yung concentration niya. If you're going to look at the cell potential, it's not really the one that we assign. There are some factors that we have to consider. Okay? Now, they also use this so-called formal potential. So this is just to compensate for problems with cell potential in using activity and with side reactions. So based on the conditions of 1 molar concentration with all species being specified, like HCl versus perchloric acid as acid, and the formal potential will give better agreement than the cell potential with experimental data and Nernst equation. So the conditions need to be similar to conditions where the cell potential is measured. And also you have to consider the reaction rates. Now, some of the cell potential half reaction listed in the table have been determined by calculations from equilibrium measurements rather than the actual measurements of the half cell reaction in an electrode system. So for instance here, your carbon dioxide reacting with hydrogen ion producing oxalic acid, its cell potential is equal to negative 0.49. Now, why is the reaction rates affect this cell potential? Sometimes the reaction is slow and it's difficult to see it in practice. So you have to look at this thermodynamics and kinetics condition. Okay, so usually since mabagal, how fast or slow the reaction is can affect your cell potential. And there's usually no suitable electrode that measures this type of problem. So as much as possible, gusto mo mas mabilis. Okay? So potentially it's useful for the so-called computational process. So yan yung problem na ano nila. And during this time, you can consider now the so-called liquid junction potential. So this is the potential that develops whenever two electrodes of different ionic composition comes into contact. So this occurs due to the unequal distribution of cations and anions across a boundary as a result of the difference in rate at which ions migrate. Okay, so if you have this porous diaphragm here, okay, so you have here like a junction potential. So you have a different concentration but the same species, HCl. So one is 1 molar and one is what we call 0.0 molar. So how does it travel? Usually from more concentrated to less concentrated. So lahat ng ions na meron dito mostly magmamigrate papunta doon sa less concentrated. Okay? So both the H plus and the chloride ions would move from high to low concentration. That's entropy. Okay? It happens spontaneously. And the H plus, which is more, we could say smaller, H plus smaller, it is more mobile relative to the chloride. And the H plus would move more quickly. But what happened, after some time, you're going to develop equilibrium. Okay, so it's just what happened during the junction potential here. This results in the separation of the positive and the negative charge and the creation of the potential. But after some time, mag-equilibrate din sila. Okay? So the junction potential can be more or equal to 30 millivolts. So for simple system, you can calculate it if you know the mobility and concentration of all ions. Now you can decrease the junction potential by using the salt bridge containing concentrated electrolyte. Okay. Now the best mobility here if the ions are equal, the charge of the ions are equal, or if you use 4 molars of KCl or potassium nitrate, higher concentration, and this would result in a decrease in the junction potential to a few millivolts. Okay, so yun yung effect ng junction potential. Now, let's go on the so-called currents in electrochemical cells, because that's one thing that we're going to encounter. So you're familiar with Ohm's law, right? So Ohm's law is just the potential equals to current times resistance. Okay. So if you're going to look this diagram here, so this is what? That's the potential, and this is what we call the resistance. Okay. And if you're going to look at this, so the current is just equals to the potential divided by the resistance. Okay. And we're going to encounter later on ano ibig sabihin nitong Ohm's law na to, how it affects currents in the electrochemical cell. So usually, there's a transport, okay, mass transport resulting from current in bulk solution. So anong nangyayari dito? Yung current sa solution, they are carried out by the movement of ions. So between this one, alin yung ions natin dito? Yung H plus. Tapos yung tinatawag nating chloride ion. So again, alin yung mas smaller dito? H plus is smaller than the chloride. So that means they will move faster, okay, compared to this what we call chloride. And they're going to carry what? More current than the larger chloride ions. So the species reacting at the electrode don't have to be the only species carrying the current. So for example, if you have much higher concentration of other current or much higher concentration of larger ions, let's say meron ka ring KCl doon, okay? So what happened then? This will carry current in bulk solutions. So usually the analyte that you have will carry current only in region near the surface. So this is before the current, and then after the current is applied. So ang nangyayari, makikita mo mag-aano na doon sa electrode. Yung magkakaroon na ng mass transport from the bulk solution going to the electrode. Okay? So this will be helpful when we go in each of the method that we're going to discuss, especially voltometry and coulometry. Okay, so what are the currents that we have in this so-called electrode surface? So it could be Faraday current or non-Faraday current. So if we're going to look at this Faraday current, this is the transfer of the electrons to or from the electrode by redox reaction. And since this is a redox reaction, involved dyan yung tinatawag dito. This is governed by the so-called Faraday's law. The amount of current is proportional to the amount of species that's oxidized or reduced. Diyan yung ginagamit natin yung Faraday constant. 96,500 charge per moles of this what we call electrode. Okay? So, yan yung Faraday current. Now, the non-Faraday current, so these are due to the other process aside from the redox. So we could say this is all redox. This is non-redox. Okay? Example dito yung charging current natin. So when first applied potential to electrode, it gets the redistribution of ions near its surface to counter the charge on electrons. So the movement of ions that result in current. And as the system approached equilibrium, what happened? Okay, it decreased in ion movement and current. So yan yung mga nangyayaring ano doon sa electrode surface. Okay. Now, you can also have a mass transfer in the cells with the passage of the current. So, yung tinatawag nating Faraday current, it requires the continuous mass transfer of reactive species from the bulk solution to the electrode surface. And three mechanisms are involved there. Yung tinatawag nating convection, migration, and diffusion. And we're going to encounter them again because ito yung tinatawag natin mechanisms that happen in a Faraday current doon sa surface ng electrode. Sa pag-convection, it involves mechanical motion of the solution as a result of steering or the flow of solution past the surface of the electrode. So ito yung ini-steer mo yung system. Now, yung migration naman, ito yung movement ng ions through the solution brought about by electrostatic attraction between the ions and the charge electrodes. So merong tinatawag natin opposite charges attraction. Okay? Yung diffusion, this is just the motion of species brought about by concentration gradient. So, pagdating na doon sa surface yan, different mechanism ng mass transferred ang nangyayari. Okay? Ma-encounter din natin yan later on. Okay? So, ano yung effect ngayon ng current doon sa tinatawag nating cell potential? So, the potential can be listed as this, what we call standard cell potential or some sort of a potential in tables that are thermodynamic values. At equilibrium, okay, since wala kang potential, wala ka rin current. But in practice, you have to make sure that some current is always present. And current can either decrease in measured potential for the galvanic cell or increase in potential needed to drive the electrolytic cell. Okay? And here, we're going to look again at the two main sources ng tinatawag nating current effects ng cell. So meron tayong tinatawag na ohmic potential. That's why I introduced to you the Ohm's law. So ito yung tinatawag na current resistance drop. So what happened here? The flow of the ions or the current through the solution, okay, passing through the resistance, it gives potentials across cell according to Ohm's law. So if you have an ohmic potential, you need to subtract from your cell potential calculation to get the true potential of the cell. So i-consider mo yung Ohm's law. Okay? Aside from doon sa the usual calculation, the potential of the cathode minus the potential of the anode. But you have to consider here, okay, yung tinatawag nating IR drop. Now, another thing that we have here is the so-called polarization effects. So this happens in many electrochemical methods where you use current versus the potential curve. So this is an example. Okay, so this is the current, and this is what we call the voltage. So what happened here during this polarization? Okay, yung term kasi na polarization refers to the deviation of the electrode potential from the value predicted by the Nernst equation. So if you're going to look at these polarization effects contribute to the nonlinear regions of the curve. Okay, so nag-deviate siya. So usually at high or low cell potential, you get less positive or negative current than expected. And this is due to polarization. So what happened here, the solution or reaction cannot keep up with the changes in the potential of the system, and it limits the rate of the overall reaction. Now, there are some factors that affect this, what we call polarization. Okay. And these types of polarization could result in the so-called slow mass transfer or the so-called concentration polarization. And again, lumabas na naman dito yung three types of mechanism. Mass transfer to diffusion, which is concentration gradient, migration, which is ions would move in potential, and convection due to mechanical steering. Okay? And this would result in what we call slow intermediate reactions, okay? And the slow transfer of electron between the electrode and the species. So what happened here is you have a charge transfer polarization, okay? So pwedeng mangyari just any combinations of this process. It can be mass transfer, chemical reaction, or physical state change dito sa polarization. So the factors that can affect polarization: electrode size, shape, okay, and composition. And then the composition of the electrolyte solution, yung temperature, okay, yung steering rate, the mechanical steering, yung current level, and the physical state of the species as shown here. That can also affect the polarization or influence polarization. So what they do, okay, to serve some sort of degree of polarization of electrode, they have this so-called over voltage or over potential, which is just the difference between the actual potential current and the equilibrium potential. Okay, so what happened here, the polarization, when you have over voltage over potentials, always reduce the electrode potential, and way here is always what we call negative. And this is sometimes useful in over voltage because high over voltage is associated with the formation of H2 and O2 from water, and high over voltage, okay, means it takes much higher energy than the cell potential to occur on many electrodes, and it can deposit metals without hydrogen formation and interfering with electro deposition process. Now, I introduced this because these are the common methods when we discuss especially coulometry and voltometry next time. Okay? So yun yung parang introduction doon sa main course natin with regards to electroanalytical technique. Now, I'm not sure if the metrum, there is an electrochemistry research lab there, if it's still functional, but I think I did when I went there into 2018 to work with Mambiki. That's what we did. We tried to characterize the electrochemistry of some waste that can be found in the industry. Okay, so we try to treat this waste. So one way to characterize it is by looking at this electrochemical composition. So tanong. So after today, we'll just meet 3 more times. So kailan tayo mag-quick quiz? May isa pa tayong quiz sa vibrational, tapos yung mass spec, ilang quiz nyo gusto doon? Isa na lang? I think we need to do it this week, and then siguro labas ako ng problem set, tapos i-deadline natin sa 21 lahat yung problem set. And then after that, hindi namin kayo i-disturbo kung ano man yung final exam schedule, doon na lang tayo mag-aano muli. And I think after 21, doon lang namin mag-grade lahat ng ano nyo.
Mahirap mag-check eh, walang oras talaga. Grabe.
And it make it harder dahil online. Hindi ko naman kaya mag-print, mauubos yung ink ko. Ano nga, yung classic ko, one will end on 18 and the other one, we still meet, I think, until the 21st. Oh no, yeah, the final exam that I have at place is 21st. Okay. The one at York is 18. And then after that, puro grade na. Tapos guguluhin ng mga estudyante. But at least for you, after 21, kung ano man yung deadline natin doon, we're not going to disturb you. And then we just wait kung ano yung date nung, I think final exam is between 5 and 11 of January, if I'm not mistaken. So we will definitely finish electroanalytical by next meeting, and then radiochemical and particle size method next week. And then that's it.
So magmi-meet pa tayo ng December 16.
Opo. Iniisip ko nga kung kaya sa 14 yung parehong ano eh. If ever, we will see, okay? I'll try to see if I can pit them. Kasi ang ano lang naman yun yung principle, and the only, I have a radiochemical isotopic analysis in Dr. Aga's lab and also some dynamic light scattering. Pero hindi ko talaga nagamit eh. But there's an instrument in Dr. Desamero's lab that is not being used.
Sayang ano?
It was ordered, and then the one who's supposed to use it was gone. And he asked me if I can do it. But they use it for nanomaterials study, the dynamic light scattering. And during that time, hindi na ako makabalik doon because the nanomaterials that I have is I look at protein and how it interacts with nanomaterials. So we see it, what we call that when you add certain nanomaterials, the reading goes down. So what we try to do is we try to look at the particle size. Ano yung size ng nanomaterials na nagbabind doon sa protein. Usually yun yung main focus ng dynamic light scattering. Yeah, maybe we can have 2 more meetings. Yeah, siguro yung last ano doon, yung sa 6, I think it's just one problem set. And if you're going to look at the material, merong ano, although hindi sila naglabas doon sa study guide, but if you're going to look at the study guide, especially here sa I'd like to share it to you, sa electroanalytical, may mga links silang nilagay. But I tried to cover it with our lecture today. But if you're going to look at this, these are the things that you have here. In fairness, I realized it's 16 pages. That's why originally I was just planning to give you the 3 methods right away. And then when I read it just today, kasi akala ko mga 4 pages lang. And then I realized, I said, oh no, I have to talk about, kaya kita nyo, meron tayong balancing, because it says here, you may need to review how to balance redox reaction. Kaya parang nag-review ulit tayo dito sa Chem because it asked me to do it here. Kasi if you look at the other study guide like this one, so you have isotope dilution, so this is the one after this. Okay? Because I usually just look at the objectives, the learning objectives. Yun lang yung talagang tinitingnan ko. But if you're going to look at the learning objectives here, ito lang, oh, basic principle of electroanalytical techniques. Tapos explain principles of potentiometry, colorimetry, and voltometry, and apply in real thing. Then I realized, I said, why is it asked to review this thing? That's why I have to prepare the materials. Most of the materials are from my Gen Chem and Analytical Chemistry. But the original one is really to what we call focus on this one. So next time we focus this one. And for the real samples, I think you can watch the video that I posted. Kasi nandun yung parang research na ginawa ng mga student ko on how they apply it in real sample, which is just metals in water samples. So I would suggest just look at the guide here because there's a link that you have there. Okay, but I make sure I covered everything here tonight or today. Kaya magtataka kayo, oh, bakit tayo may mayroong balanced redox reactions? And why do we have this what we call nurse equation? And it's made easy for me because that's the courses I'm teaching also this semester with Gen Chem 2. And they have an exam, their fourth exam this weekend. So kakatapos lang namin mag-discuss ng electrochemistry. So question. Sa 7 sumipot out of 42. O 41 pala. So magre-release ako ng quiz before we meet on Thursday. Okay lang sa inyo? At least yung vibrational? Like a 5, maybe 5 true or false question in what? 15 minutes? What do you say? Kayo magre-represent doon sa 41 students. So I'll make it available by maybe tomorrow night yan, tomorrow morning dito. And then, and deadline is before we meet on Thursday. Is that okay? Yun lang. And then maybe in the weekend, I'm going to give you the quiz for the mass spec at saka yung electro, I mean yung problem set.
Ayan, sumagot na si Alicia. Ayan, sumagot, nag-thumbs up na sila. So, 5 questions of true or false, 15 minutes.
No. Anything about vibrational spectroscopy. And then I'll do the, siguro, if I'm not mistaken, you will have 1, 2, 4 problem set, but it will be short. It's not like the one that we have before. Kasi pag mahaba, nahihirapan din kami mag-grade. Hindi ko kasi nagawa last time because I have my booster. Although it's not as, we could say, painful as the second one, but still.
Okay ba yung Thanksgiving celebration?
Okay lang.
Maraming lumabas.
Kaso, meron kami, nag-ano kami dito. Hindi nga lang sumipot yung mga Pinoy. Kasi natatakot din ata silang lumabas.
Pero may turkey.
Hindi ho. Kasi hindi namin nauubos. Masyadong malaki.
Malaki kasi.
Filipino pa rin kami. Yung, marami na ho kasi dito yung magka-take out lang. Minsan nga hindi na kami nagluluto. Sometimes they deliver it to us. So yun yung mas maganda. Kasi yung pareho lang yung, sabi, yung misis ko nga sabi niya, pareho lang yung